I'm Andy Jeffrey. I'm a father, a husband, a teacher, a mathematician, and a trainer of teachers.
And what is the link between magic and mathematics?
I forgot to mention magic. I think maths is a magical thing. A lot of children see maths and they don't get it, and then everything's hard until you can do it in life. And I see a parallel with magic and maths there, because magic's one of those things that you go, how's that done? And you wonder, and I love that sense of wondering in maths to find out how something's done. So it's great when they do find out. There's so much underconfidence in the population at large, and in the teaching population, and amongst children, about mathematics, because it's such a difficult and abstract thing for them. So the fact that you can't survive in the world without being mathematical means that if I've got any skills at all, I can use those in mathematics to help children understand it. So for me, that's what excites me about doing what I do. I've got a great job. I'm so lucky. The Numicon isn't a phrase that I've used before. There are various aspects of it. I think when most people think of Numicon, they probably think of these little shapes with various bits of plastic and colours and holes in them and what have you. But Numicon is so much more than bits of shape. It's actually an approach to learning of mathematics. Mathematics is a discourse, it's a conversation, whether it's between two people or between one person and themselves. So thinking is having a conversation with yourself. And you can't write or anything unless you've actually done it. This is the principle. So action, doing something, imagery, looking at something that looks a lot more six-ish than just like a curvy shape, and conversation, describing what you can see, what's the same, what's different, what's bigger, what's smaller, how do things relate to each other. So lots of action, lots of imagery, lots of conversation, and then lots of looking at structure, and that allows us to generalise. So for example, if you know that 2 plus 3 is 5, which is a deceptively difficult idea because you're saying 2 of anything plus 3 of that thing is 5 of that thing, but you can't ever see 2 of anything, you can only ever see 2 of something. That's a very difficult kind of idea, so we move too quickly from 2 bears to 2 for children, often, and that's what causes the confusion. But once you know that, you're so powerful, because that's what algebra is all about. It's about making those generalizations. You know that 2 billion plus 3 billion is 5 billion. Even if you don't know what a billion is. What makes it a fun way to learn? Well, I think any learning can be fun if it's delivered in the right way. I think the fact that it's interactive, so there's no sort of passive, you speak, I'll listen kind of thing going on. Not that I don't think children should listen, but it's about forming a hypothesis. It's about getting children confident. For example, when I was at school, I was told that 2 odd numbers added up to an even number. I just had to learn that as a fact. But consider this: there's an even number. 1 more makes it an odd number. There's an even number. 1 more makes it an odd number. 2 odd numbers together is always going to be an even number. And what's beautiful is I can generalise that by appreciating the structure and saying, you know what, however long this piece went, if it went on forever, in pairs it would still be an odd number. And the same with this one. So effectively, any 2 odd numbers add up to an even number. Well within the grasp of very young children. Well, this is an important point, that no system or scheme differentiates. It is teachers who differentiate, and that's the skill of the teacher. One obvious way is that if I say to you what is 3 plus 2, some children may need to physically take out, let me say 3 plus 4, because otherwise I've lost the 2. 3 and 4 can be put together and added like that. Now I don't have to count that, I can calculate that, and I can compare that to 7 and see that that's simply the same. Other children may be able to simply close their eyes and visualise those 2 pieces. Other children have simply internalised that to such a degree they go, it's 7, I just know it. And that's gone into their memory. It's what I call 1066 country. In other words, people in this country will know that the Battle of Hastings was in 1066. They don't even know how they know. They've just internalised it. Ooh, I think there are a few right principles. I think I'd rather go with that. Once you understand the principles, which is that children need to construct concept images of numbers, how they relate to each other, and the way that we calculate with them. I think once you understand those, then there is a whole range of different ways you might choose to use the pieces. For example, when children are young and introduced to Numicon, they're not worried about the numbers they may represent. They're just things for them to play with, get used to, combine in different ways. And as they get older, they start to say, well, what if that was 1? And they link that with the word 1 and the shape 1. They look at other things. They might look at that or that 6, and they might link it with that symbol. They might notice that that's different, okay, and so on. But as they get older, who says it has to be 1? See, supposing just for a moment that was 1. Now suddenly I have a whole new understanding of this. It's a tenth, or 0.1. And here's 4/10 or 40%. So very flexible, very versatile. So in the best schools, the schools who have invested in training in Numicon, and that doesn't have to be from the Numicon people, it can be from anyone who's qualified to do it. But the Numicon people know who those people are. Then they'll start to see what it's about. They won't say this is a 6 because you can count there are 6 holes. They'll know that that's just a temporary step in the journey. So the schools that have had training, in my opinion and experience, tend to make much better use of the Numicon if they remember that it's about looking for patterns and looking for relationships. Numicon have a team of dedicated consultants. Sorry, I don't want this to sound like an expert, but as you are. There are also affiliate trainers who don't work for Numicon particularly, but who might work for education authorities or independent consultants, and Numicon offer them some training as well, so that they can go into schools. I think it's really important. It's really nice. It's for teachers to train each other as well. Sometimes it's just nice for teachers to sit around and go, what did you do? What did you try? I think we learn so much more that way. Is Numicon part of the curriculum? No. Because it's a commercially available product, it's not allowed to be part of the curriculum. But the curriculum, and recently Ofsted have said, you know what, children will learn better if they can manipulate concrete resources. You know what I mean? Resources. And anything visual, any imagery. I think the role of imagery is being increasingly well understood actually in this country at the moment, which is exciting. So for example, how many different ways can I cover that with just one colour? Well, I can cover it with orange ones. I couldn't cover it with these light blue ones. I couldn't cover it with these yellow ones. And this is about factors and multiples and prime numbers and square numbers. All, you know, for older children as well. Plus, as I mentioned earlier, you know, if that's 1, that's 90%, 60%, so 0.6 and 0.9, for example, will turn out to be 1.5. It's not just for younger or less able children. Is that bigger than that? Okay, so those two things look exactly the same size, but actually this one's a bit bigger. Trust me, this one's a bit bigger. Now I'm going to make it bigger still. You see how difficult that is? The language of this is not really 5, is it? It's a secret code. It's like a musical note. You see a musical note written on some page. You're not really looking at the musical note. You're looking at a secret code that's invented to represent it. And this is the same. This is a secret code. Now this is not 5. We've just scrawled a symbol. This isn't 5 either. This is 5 fingers, which is 5 of something very different. And let's be honest, that's not 5 either. But there's something that's more 5-ish about it than that. So one of the difficulties is that it uses familiar language in an unfamiliar way. Well, the really hard words that we use, so it's the numerals, it's the abstractness of it. That's what this kind of multi-sensory approach is supposed to represent.